the mechanic or scrapman has to pay £1 for it to be disposed of. This is because they are classed as hazardous waste, so their disposal in landfill is heavily regulated.
Currently, many ways of recycling tyre rubber just aren't worthwhile, or have cheap synthetic alternatives that prevent them from being cost effective. Because of this, most tyres end up going to landfill or stockpiles. Melting down tyre rubber into a mouldable state isn't possible because of the process during manufacture called vulcanization.
We are the TechHEds, the technological home educators, and for our 2015 Trash Check project, we started by brainstorming or mindstorming for items of trash that we thought could be recycled or reused better. We came up with 4: polystyrene sheet packaging, tyres, lollipop sticks, and used clay targets.
To help us in our brainstorming, we took a visit to J. Jones and Sons scrapyard in Devizes. While taking a tour, we asked the manager what was the hardest part of a car to recycle or reuse. He answered, the tyres. After this, we took a vote and decided our item of trash research was tyres.
Currently, tyres are sent to one of several companies who chip it up into crumb rubber used in playgrounds and sports surfaces, floor matting and rubberised asphalt. However, with used tyres having limited reuses, there are still 48 million tyres, that equates to around 480,000 tonnes that are stockpiled each year in the UK alone.
So, our solution is this: to put crumb rubber onto the top surface of roads. We call it Surface Rubber Modified Asphalt, or SRMA for short. While a road is being laid or resurfaced, a thinner layer of asphalt than usual will be supplemented by 10 to 20mm diameter particles of crumb rubber. This rubber will be dropped onto the hot asphalt, and as the asphalt is flattened, it will be pressed down and firmly encased in the road surface. The reduced amount and therefore cost of the asphalt would help compensate the extra costs of the crumb rubber and the machinery required. The thickness of the asphalt would depend on how much rubber the road laying company chose to put down, as well as the amount of rubber available.
This solution would be implemented by adding a second hopper for the rubber to existing paving machines. This hopper would supply a type of sprinkler that would evenly drop the rubber at the right speed onto the hot asphalt just before the screen, which is the part of the paving machine that finally flattens the hot asphalt, levelling the road surface.
The extra costs would be the one-off cost for the second hopper and dispensing mechanism, and the price of the rubber crumb, which would be approximately £55 per tonne. We would recommend using around 9 kilograms for every square metre of road. However, the amount of asphalt replaced by the rubber would be chosen by the road laying companies. If they laid our recommended amount of crumb rubber, they would use around 12,000 tyres for every kilometre of standard single carriageway A road.
At present, crumb rubber is used in RMA, rubber modified asphalt, which distributes the crumb rubber inside the road in one of several ways. However, our method differs in that the crumb rubber is laid on top of the road, not changing the durability of the core road.
Due to the innovative way that our solution is implemented, there could be some problems which would require further experimentation. However, our solution has many advantages. There are around 400,000 kilometres of roads in the UK, and all of these will need resurfacing sometime. With our idea, they could all have a quieter road surface. This is just one advantage of our solution. It will be more cost effective than standard roads, as crumb rubber is generally less expensive than the asphalt it would replace. Also, there will be reduced tyre wear, and it would use many tyres which would otherwise have gone into landfill, making it environmentally friendly.
In conclusion, our solution would help solve the problem that tyre rubber is expensive to recycle and dispose of. It would create a large market for recycled tyre rubber, while creating quieter, more cost-effective and efficient roads. Here is a summary of our project. We welcome any questions you may have. Thank you for listening.
Thank you very much.
You mentioned the busy routes and scrapyard at the beginning. What other sort of research did you do? What sources did you use to find out about tyres and those?
Well, we also went to Hills Waste and Revive, which is like a household waste plant. We also went to the local Wiltshire scrap store to see what kind of stuff was being put to waste. Obviously, we also used the internet, and I also used some books. I cannot use the name of them, but they were generally in other ways which tyres have been used. And I also contacted Highways England.
What sources on the internet did you use?
Just general internet.
No, I'm not. Any information you use?
So there were several websites and sort of PowerPoint things that companies primarily in the United States and Canada had put together.
And then you mentioned some of the benefits of your tyre solution. You were talking about talking to the road loading companies about how much they would want to use, how much asphalt they want to replace. Have you had any feedback from them? Have you spoken to anyone about how durable the road surface would be with your solution?
I think if we were to take this to the actual working level, I think that would probably be our next step. But that kind of information isn't really available, so it will require real-life experimentation.
Did you go back to the places you visited, or have you spoken to anyone about the solution and had any feedback on it? The idea?
As I said, I contacted Highways England, but they haven't unfortunately got back to me yet. I believe they contact Wiltshire Council about this.
Yes, pioneering.
And have you shared this presentation with anyone else?
Yes, we have shared this presentation with a group of homeschoolers that meet monthly, and we have shared it with several interested professional engineers.
Oh, who were they? Which company or?
Yes, there was one from a consumer electronics company and one design engineer.
And the other thing was, you said you talked to Rodo again about the percentage that you'd use, and you said you've got a recommended percentage. So how did you come up with that figure that you have in mind for how much of the asphalt would be replaced?
I think we were working on the still maintaining the durability of the road in the main part, but using enough, replacing enough asphalt that it would be, you would get profit from that.
What do you think would happen if you got hot weather with this rubber and tarmac mix? Would you get the two breaking apart, do you think?
I don't believe that we would do. In standard asphalt, obviously the tyre, the grit is held in place with the tar, and due to vulcanisation, the process that tyres undergo, which actually causes a lot of the problems anyway with the rubber not being able to be melted back, certainly the rubber element in the road wouldn't be affected.
How do you envisage the roller system, given that you get like hot tarmac and if you're mixing it with the rubber, which presumably is cool? How do you think that the roller would cope with that? Do you think you get stiction? I know they run water around it, but do you think you might get stiction as you lay it down?
I think once again that would be something that would have to be tried out in the real world.
Yeah, brilliant.
One of the main problems with roads is, especially once you get water seeping into the tarmac, and then as the temperature changes, it expands and contracts. Ice is big one of previous, isn't it? And that actually pushes the road surface apart, and that's how you create potholes, which are really, really bad for cars to go over. Did you have any sort of thought about how that might, what your solution might do to stop that? Because that is a major problem in roads at the moment.
We do not believe, as the rubber is only on top of the road, we don't think that it will change the durability of the main part of the tarmac.
Because it's just a top.
And also, as rubber is quite springy, then it should have to absorb some of the expanding and contracting.
What actually holds rubber together? Because your sketch showed being put on top of the normal tarmac surface. So you've got rubber crumb being introduced and spread on the top.
So, with normal tarmac, you get the aggregate and the binder, which is the tar. So we believe that if we just put rubber on the top of the road soon after it's been laid, the tar will hold the rubber in place.
And as the rubber will be sticking up above the surface when it had been dropped on, as the roller went over it, it would press the rubber into the top surface of the road.
Okay. Thank you for me.
Yes, thank you very much. Thank you.
Well done.